That means we're going to start at A and stop at B. Now, that is so easy, kids. Do not make this hard. If you start at 1, look at just the x's. If you start at 1 and go to -3, tell me how far you've traveled. If you start at 1 and go to -3. Don't say 4, say -4. Haven't you backed up 4? So your x-coordinate of your vector is -4. Now what about your y-coordinate? You started at 2 and went to 4. So that's 2. These are called the coordinates or the directed distance. Both words are used. So when we talk about the coordinates or the directed distance of the vector, we simply mean the x and the y that describes how it moves. So this vector, AB, the vector that starts at A and goes to B, that vector travels -4 in the x direction, so it goes left 4 and up 2. The vector coordinates here are very similar to slope, aren't they? They tell us how this line's moving. All right, let's do BC. What are the coordinates of BC? That's the vector that starts at B and ends at C. That's important. It starts at -3 and ends at 5. That's 8. Starts at 4 and ends at -2. -6. Easy peasy, nothing to it. Those are the vector coordinates of directed distance. So if you know the starting and stopping point, you absolutely can find the coordinates of the vector. Now, what do you think this means? It's not hard. It means 2 times the directed distance. So if AB goes left 4 and up 2, what's 2AB going to do? Go left 8 and up 4. They're moving in the same direction, but this one's just going twice as far, right? In vector land, this number, which we might think of as a coefficient, is called a scalar. The language of vectors and matrices is just different. There's a separate vocabulary, and instead of talking about a coefficient, we talk about a scalar. You guys in physics, I bet, have discussed scalars. They're simply constants. All right, let's get down to this one real quick. Now, do not make this hard. First of all, we already know what AB is. We already figured that one out. We got to figure out what CA is. Now, watch it. CA. So we're starting here and going here. What would be the coordinates of CA? -4. -4. +4. Again, do not complicate it. Use your common sense. If you're at 5 and you're going to 1, you're backing up 4. If you're at -2 and you're going to 2, you're going forward 4. Now, how do you think we might add these two together? Do not make it hard. It is so simple. How do you think we might add them?
Add the x's.
We add the x's and we add the y's. So the sum of these would be -8, 6. In vector land, the sum is referred to as the resultant. So instead of sum, we say resultant. When someone says to you, find the resultant of these two vectors, you're simply going to add them together. Resultant means sum. So 3 new vocabulary words so far. We have vector, which is a directed line segment. That is, it has length and direction. We have the word scalar, which is simply the vector word for a real number. generally a coefficient. And then we have the word resultant, which is the word for sum. Ben? You look like you're on a beach somewhere, Ben.
I wasn't sleeping. I put military pause.
Okay.
Let's soak in.
Now, we want to find D so that AB is equal, so vector AB is equal to vector CD. Now let's think about this for a second. Tell me about vector AB. You already found his coordinates. What are the coordinates of vector AB? -4, 2. So in other words, to get from this point to this point, and I haven't drawn it to scale because you don't need to, just get the idea that we're going back 4 and up 2. That's how this vector moves. You want to create a new vector from C to D that moves exactly the same way. It has to go back 4 and up 2. And it has to start at the point 5, -2. You are trying to figure out where it ends. Do you understand the question? So this new vector that you are building has to go left 4 and up 2. And it has to start at this point. So where will it end? If it starts at this point and goes left 4, where's it going to end? 1. If it starts at this point and goes up 2, where's it going to end? There you go. How easy is that? One more vocabulary word, last one of the day. Vectors have length and direction. They possess both qualities, length and direction. In vector land, you physics people know this, what do we call length? We don't refer to the length of a vector, we refer to its, starts with an M, magnitude.
Knew it.
Magnitude. Magnitude is the vector word for length. Suppose I asked you then, after going through and doing all this, let's just use vector AB. Suppose I asked you for the magnitude of vector AB, the length of vector AB. First of all, this would be the notation. This is the notation for magnitude. It looks like absolute value. But when you see the absolute value, you're referring to the length, the magnitude. This vector goes back 4 and up 2. So I want to know how far it travels. What is its length? Any ideas how we might figure that out? It's pretty easy. We could definitely use the distance formula, especially since we have the original 2 ordered pairs. Would everybody agree that the length of vector AB could be found by doing the distance formula? So what would that look like? Let's just start with that. Actually, there's a shortcut to it, but let's go ahead and do this and maybe we'll discover the shortcut. What's the distance formula say? X minus X will be 1 minus -3 squared. And 2 minus 4 squared. And I can do that subtraction in either order, right? It doesn't matter which way I go. So what do I end up with here? I end up with 4 squared and 2 squared. Actually, it's -2, but it doesn't matter because it's going to get squared. So the magnitude of the length works out to be 16 plus 4, the square root of 20, or 2 root 5. Notice something about these 2 numbers. Have you seen those 2 numbers before?
I'm blinded at the wisdom.
So to find the magnitude, I can just square x, square y, add the other, give the square root. We'll continue that discussion tomorrow. Okay? Good job. You hit the wrong button. Have a great day.